Now after we know the moment generating function, here we want to find the characteristic function. Well, find the characteristic function, most of the time you will use the table we provide. So part A, find the characteristic function of xk. You have a PDF, then by Fourier table, we know Fourier table, this one is pi times a times e to the minus a omega. So the PDF of xk of x is this pi times ak squared plus x squared. This is 1 over pi ak times the pi ak e to the minus a omega, absolute of omega, which is e to the minus ak absolute of omega. You just compare this form and this form. Yeah, since they don't have pi, so I put the pi outside, and since they have a squared, I don't have a squared, so I times a squared and compensate it in the denominator. That's the characteristic function of xk. And how about the characteristic of y? Y is a summation of all xk. So the characteristic function of y is the expectation e to the minus j omega y, and y is a summation k equals 0 to infinity xk. So this summation is like x1 plus x2 plus x3 dot dot dot. So in the exponential x1 plus x2 plus x3, this is just exponential x1 times exponential x2 times exponential x3. So finally this one is, and because they are independent, very important, they are independent. So I can take the multiplication outside and then expectation. Independent. So it's k from 0 to infinity, expectation of e to the minus j omega xk. And since we know this is the characteristic function of xk from part A, then we know here is multiplication e to the minus ak times absolute of omega, which is e to the minus summation k is 0 to infinity ak times absolute of omega. And also because ak is 1 divided by 2 to the k plus 1. So summation ak, k from 0 to infinity, is the summation k from 0 to infinity 1 divided by 2 to the k plus 1. This equals to 1. This equals to 1. So finally the characteristic function of y is e to the minus absolute of omega. And what is this? check your Fourier table. No, check your table for different type of random variable. Then this is Cauchy random variable. Cauchy random variable with the parameter lambda equals 1. So the PDF of y, because it's Cauchy and lambda width is 1. So the PDF is pi times 1 plus y squared.